Hello and welcome to York Universe, the astronomy and astrophysics radio podcast, written and presented by the students, faculty, alumni, and friends of York University. You'll now find us wherever podcasts are distributed. I'm Senna Withers. I'll be one of your hosts this evening, and I'm joined by our observatory director, Dr. Elena Hyde. We're broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday night at 9 p.m. local Toronto time or Tuesday morning, 1 a.m. Universal time currently, on our YouTube page, York U Observatory. We always run in concert with our online public viewing team, run by our observatory staff. To navigate to the live show or to find out more about us, please visit our website at yorku.ca/science/observatory and follow the links to our online public viewing to join the chat. For any questions or comments you have on our past shows, or if you have any suggestions for future topics, please send us an email at observe@yorku.ca. You can also always connect with us on social media on Instagram with the handle at York U Observatory and on Facebook at Allan I Carswell Obs. All of our programs are free, but if you would like to make a donation, please see our website at yorku.ca/science/observatory. Our observatory staff will be monitoring the chat room on YouTube for questions and to post content. We're currently going to be looking at some archival images taken in part by our 1 meter telescope at York, but we're not able to do live viewing tonight. The weather is not looking so great, unfortunately. I think we've sort of run out our luck for the past 4 nights of very good weather, so we're starting to get the clouds rolling in. So unfortunately, no live views tonight. But one very early reminder I can give that I just realized is that at around 9:30, 9:35 tonight, if you're in Toronto, you might be able to see the International Space Station come overhead. So if you have clear skies, you might be able to catch that. But yeah, we have a whole great show tonight planned, mainly space telescope themed. But how are you, Dr. Hyde?
Yeah, I'm doing great. As you say, looking at the clouds, going hum. Of
Yeah.
course, if it was clear, Mars would be um, nice and prominent. And I have to say, I have been enjoying all of the extra Mars views that we've been getting the last few nights. What was it? Gosh, oh gosh, it was about 10 days ago now. We had the close approach with the moon. I was
Yeah,
like, it was yesterday. No, it was 10 days ago. My sense of time is obviously gone,
yeah.
but
Mine is too. It's like the weekend did not exist because I was observing the whole time. So it still feels like
yeah,
it was last week for me.
yeah, and I will just apologize if I do come across sounding a bit different today. The other thing that has happened is we have everything in bloom in Toronto, and I've got the allergies big time today.
Oh no.
So a little bit of advanced apology for that. But yes, at least the nights are warmer. I don't know. This might not be a bonus actually, but
Yeah. I think the weather the evenings this past few days have been amazing. I've
yes.
had my windows open all night, so it's been probably a bit cool for most people, but this is my favorite temperature.
Yeah, I have to agree. I think that, April and May, other than the allergies, it's quite a nice time of year in Toronto. And we still get a reasonable amount of dark time for the evening, although that's quickly changing as we move, of course, into the summer.
Yeah, yeah. I think we were only opening the domes around 9 p.m. the past few days just because it was just
Yep.
too bright out. So this is starting to reach my limit of, unreasonably late sunsets. But
And it'll be too warm tunes soon, but
yeah,
at least we still have good armchair stargazing nights, which is something to look
exactly.
forward to.
Yeah, exactly. But one thing we could do on cloudy nights is just talk about space.
Absolutely, and of course data reduction. But let's talk about space first. I think
Yeah.
it looks like you've got the first item. Do you want to go first?
Yeah, sure. So for the first This Week in Space and Astronomy History, I'll be taking us back to May 14th, 2009, which was the launch of two very important space telescopes, the Herschel and Planck observatories. Both of these observatories are run by the European Space Agency, but they also have collaboration with NASA. And the pair of telescopes were basically launched together in a single Ariane 5 rocket from Europe's spaceport Kourou, French Guiana, which is where many important space telescopes, including JWST, have launched from. So I'll just talk about a couple of the important sort of highlights from both Herschel and Planck. Both telescopes, as I'll mention later, are decommissioned. They were decommissioned actually a very short period of time after they were launched, at least I think it was a pretty short period of time. But both of these missions were incredibly successful and were very, very revolutionary. So Herschel in particular, I just want to mention also then how these space telescopes got their names because these are also pretty interesting. But the Herschel telescope was actually named after two astronomers, the siblings William and Caroline Herschel. They both have very, very long resumes and lists of accomplishments, but a couple of the sort of highlights I could mention right now is that William Herschel was responsible for discovering infrared radiation. So this telescope was very fitting to be named after him, as I'll get to in a second. And his sister Caroline Herschel was also the first woman to discover a comet and was awarded the gold medal of the Royal Astronomical Society for that and a lot of her other work in astronomy, including several discoveries of comets and for cataloging many stars in our galaxy. So the reason that the Herschel telescope was kind of fitting to be named after William Herschel for discovering infrared radiation is just that it is a infrared telescope. In particular, it looks at kind of the longer wavelengths of light, the far infrared to submillimeter, which is kind of the far infrared to radio range of wavelengths. And it's a 3.5 meter diameter telescope, which at the time was pretty crazy. This was the not only the first space telescope which was able to observe submillimeter wavelengths, but it was also the largest infrared space telescope that had ever been constructed. So it was able to do a whole lot of science that had just never been possible with previous generations of instruments. So we definitely don't have time to talk about all of the amazing things that the Herschel Observatory discovered. But just a couple of highlights. It was able to study planetary atmospheres in our solar system, which also included observing comets and moons. It was able to observe the formation of protoplanetary disks. So these are the very early stages of planetary formation that would later evolve into actual planetary systems and actual planets. So it was kind of just starting to unlock the early stages of planet formation. On top of that, it was also unlocking the early stages of star formation in general by observing partly these very long filaments of gas that would later go on to collapse and form stars, and was also responsible for the first robust detection of molecular oxygen in space. It was previously kind of suspected, and there had been some hints that of molecular oxygen in space, but the detections were not necessarily robust, and the Herschel Observatory was the very first observatory to provide real hard evidence for, molecular oxygen actually existing in space. Now moving on to the Planck Observatory. This one was named after Max Planck, who was a theoretical physicist who had won a Nobel Prize for his work on quantum theory. Now, Planck was kind of a different type of telescope to the Herschel Observatory, where Herschel would observe more specific targets like planetary disks or star formation regions. The entire point of the Planck Observatory was actually to just do these massive all-sky surveys to learn important information about our the cosmology of our universe and cosmological parameters. So what Planck did is it actually surveyed the entire night sky or most of the night sky using radio wavelengths. I believe it was also submillimeter wavelengths, particularly to observe the cosmic microwave background radiation, which is essentially just the afterglow of the Big Bang. This is sort of the furthest back in time that we can actually observe, dating back to around 380,000 years after the Big Bang. And by observing the sort of cosmic microwave background, you can learn a whole bunch of different things, like about the expansion of the universe, the Hubble constant, the age of the universe, and also the different quantities of matter in our universe. So how much of the universe is baryonic matter versus dark matter or dark energy. Now, the Planck Observatory was a massively successful mission, and a lot of the results from Planck are still used very, very often today. I think I've cited Planck. Everyone's pretty much has cited Planck in a paper at some point or another. But it did major data releases in 2013, 2015, and 2018. The first data release, or the first two data releases, included the first batch of data from Planck and then was updated with more data or observations in 2015. And then finally, the last 2018 release was basically just a new release that included updated processing so they could get a better estimates on properties out of the Planck Observatory. Again, like the results from Planck are used all the time, even today. The most recent paper has over 10,000 citations, just to put that into context. So it's a very hugely successful observatory. Now, both Planck and Herschel spent their lifetimes at the Lagrange 2 point. It's about 1.5 million kilometers away from the Earth, and it's sort of considered this like e little equilibrium point where the gravity from the Earth and the Sun can be thought of as, kind of canceling out. So if you put a space telescope there, for example, it's a relatively stable place for it to sort of stay in orbit and live its life. It's also very far away from the Earth and the Sun, so basically the bright things in our solar system. So it helps to kind of keep those telescopes cool, which they need to be. Infrared space telescopes need to be cold to operate and function properly. So it's a really perfect place to be putting infrared space telescopes like Planck and Herschel and many other infrared space telescopes as well. Like I had mentioned earlier, both of these telescopes are now decommissioned, both in 2013, Herschel in June of 2013, and Planck in October 2013. So only a few years after they launched. But they were both very, hugely successful missions, really great scientific discoveries that came out of these. So May 14th, 2009, the launch of both of those observatories.
Yeah, really huge game changer for a lot of astronomy as we know it. I think you're absolutely right about the citations, and it's quite funny with the Planck telescope. I think anyone who hasn't cited the Planck telescope has probably cited the theoretical physicist Max Planck.
Yeah.
So it covers everyone from, experimental through theory. You're gonna cite one of those Plancks for sure.
Yeah. Yeah, exactly. It's like every paper I read, there's a citation to the Planck Observatory about how its measurements of the cosmological parameters of the universe. So it's just like influences pretty much every I don't know, astronomy paper, but has influenced many, many, many astronomy papers. It's
Yeah, and
pretty
especially,
enough.
observationally, of course,
Oh
I
yeah,
think we tend to read more, well, at least I read a lot of observational papers
me too.
more than the theory papers. But yeah, it's just been, for the, you know, I would say comparatively short lifetime that they had, um, they really made a massive difference.
hmm Yeah, I mean,
And
it was what, 4 years from launch to decommissioning, and that would include a number of, a bit of time to actually commission the spacecraft, have them actually travel out to L2. So, uh, only a couple of years, especially when you compare to other space telescopes like Hubble that are still going after how many years, but very, very
yeah.
successful missions, even in their short lifetimes.
Yeah, exactly. And it's worth remembering that even the so-called short missions can be really big game changers for science, as obviously these were.
Hmm
Um, and it's also interesting that as we go, off to your telescopes, I always find it really interesting when we're going into those longer and longer wavelengths because it's worth kind of remembering when we talk about, infrared and radio, what we're really talking about is all stuff that absolutely cannot be seen by humans, but can be felt and experienced in different ways here on Earth. So especially, what I always like to do is sort of start with, okay, so we can see light here on Earth, and that gets us the visible spectrum. Those are light waves that are, in the 7 to 900 nanometers, or 10 to the minus 6, as it's called. If you're looking at just tiny, tiny, tiny light waves, and they're so small that basically they're the size of the protozoans that we have, here on Earth running around. So that's what we actually see as light. And then as the wavelengths get longer and longer, we can't see it and perceive it with our eyes. But infrared, where you're getting wavelengths the size of, a needle point or something, gigantic, or longer, that's where we actually can have heat sources that tend to radiate at those wavelengths. And so if you've ever, I always like to call it the predator vision because it's your heat vision goggles. If you've ever seen any kind of heat vision or watched the original Predator, which I do recommend, um, that heat vision that's your infrared, and that's that needlepoint sized wavelength that we can't actually see, but we can kind of experience and relate to things here on Earth. And then, of course, as you go out to radio, you get larger and larger and larger, and eventually your wavelengths are bigger than buildings. So it gets to be really interesting to think about when we construct images with these telescopes, and of course, with Herschel and Planck telling us, different physical things about what's happening out there in the galaxies and stars. And I think that maybe that leads me on to another interesting space observatory,
Also infrared.
which is also infrared. Yes. Speaking of heat vision, just to keep the infrared theme a little bit, and also space observatory, I'm going to hop a little bit of a different year, but not by too much. 1998, on the 16th of May, so that's 4 days from now, back in the past of 1998. There was an observatory that maybe didn't get quite as much press as Herschel and Planck. It was called the Infrared Space Observatory. So very original name. It's Infrared Space Observatory, and it observed in infrared. It did have an acronym, so they did go to the effort of making an acronym. It's also called ISO. And this was from the European Space Agency, so a little bit of a different space agency. This space telescope was also designed for infrared light, and it was actually a cooperation with something that was known as ISAS, and which is now part of the Japanese space agency JAXA and NASA. So it actually was a little bit of a fun collaboration. And it was designed to study wavelengths of 2.5 to 240 micrometers, which, starts to get slightly larger than the tip of a needle. Um, and it operated from 1995 to 1998. So this was another, I would say, relatively short range or short duration mission. And the ISO Space Telescope was kind of an interesting collaboration and amalgamation, I would say. So this actually started back in the 1980s when the US and the British and the Dutch started looking at infrared astronomy and seeing if we could do all sky surveys at infrared wavelengths. And this was part of that sort of infrared mission expansion that as you say, may have contributed to some interest in, especially in Planck later on. I'm not exactly sure, but it seems like it might have. And they had a lot of studies and interest around, especially in Europe. And once they had come out and ISO was able to launch, it was kind of a fun one because this one was also launched in a bit of a similar way. So this was also launched in French Guiana, and I think yours was also launched at Guiana Space Center. Was that what you said, Senna?
Yeah. Yeah, it was also launched there.
So very popular space center for launching from, but maybe one that we don't necessarily talk about quite as much on this show. But it's the launch infrastructure is built on land owned by the European Space Agency, and it's in French Guiana, an overseas region of France and South America. And the launch craft they used was one of the, reasonably famous Ariane 4 expendable launch vehicles, which you see all kinds of, these sort of smaller, so-called smaller missions using. So it was, in a lot of ways, kind of a similar mission or a, progenitor mission. And because of the infrared nature of the light, they did need to keep careful track of what kind of heat that they were generating from the telescope. And having things like thermal control was really important, as well as, of course, altitude and orbit control, and of course, being able to send images and communicate back to Earth. The optical telescope was, probably a bit bulky by today's modern electronic standards, but basically what they did is once they launched it, they tried to point it such that it was always away from the Earth and the sun, but also the moon. So major sources of infrared radiation, as you were saying. And we also tried to stay with this mission, ISO, away from Jupiter, because even Jupiter was a little bit on the hot side. Although sometimes looking at Jupiter in the infrared is a good idea. So if you want to get fabulous pictures of beautiful clouds, for example. Um, but yeah, the ISO was actually launched in the as part of this mission, and it did last a reasonably long time. It lasted until 1998, which was the this day in history, but I have to make sure to say it correctly because it was launched on 17th of November 1995. So by, I guess, starting with the end date, we have to say linear time is not necessarily a great friend of mine at the moment, but we can do it. And it basically lasted until the coolant depleted, and at that point it was going to get too warm for the infrared instrument to work properly. Because of course, if you're looking at heat vision, you're looking at predator vision, any heat you're generating is going to be a big problem. So you have to keep your telescope quite cool and make sure the temperature of the science instruments don't get to the point where they're so hot that they're generating a signal larger than what you'd want to see. And in this case, they had to cut the line when the temperature of the science instruments had risen above 4.2 Kelvin. And that was the line where they ceased the science observations, which is very cold, but it's too hot for the ISO. And of course, at the end, they lowered the orbit of the ISO once they had finished to ensure that it would sort of burn up in Earth's atmosphere. In about 20 to 30 years after shutdown, I believe was the plan. And it was switched off in 1998. So everyone can do the math, I suppose. And we're talking about last week we talked a little bit about satellites re-entering Earth. So this I might be one to watch out for. I haven't had a chance to go and check what its orbit is doing at the moment, but presumably it's still being tracked, and it's a very interesting telescope in a very interesting time, and of course, very successful for what it was, a small telescope that came up for a few years and did great things.
Yeah, it's always interesting to hear about some of the like the precursors to a lot of the telescopes, like later generations of telescopes. Um, no doubt the things that were learned from the Infrared Space Observatory would have been important for later generations like Herschel or Planck or eventually Spitzer. So, it's always interesting to kind of hear about some of the earlier telescopes as well.
Yeah, and I mean in the documents for ISO, they don't actually mention that they're an inspiration to the next missions, but you because some of the same people work and publish in both, I think that it's a reasonable conclusion.
Yeah.
But speaking of interesting missions, I see that you've got, as you say, a really interesting one here.
Yeah. So the past two were shorter timescale infrared missions, and now this is a very, very long timescale, mainly optical mission. So May 18th, 2009, which was the final servicing mission to the Hubble Space Telescope. So I think most people will be familiar with the Hubble Space Telescope, at least from the amazing pictures that sort of NASA or ESA will publish online. But basically, Hubble is this 2.4-meter diameter telescope, which primarily studies optical light, but does have a little bit of coverage also in the UV and infrared as well. But again, primarily an optical telescope, so sees the same kind of light that we do. Now, Hubble itself was launched in 1990 on the Space Shuttle Endeavour and has spent its entire lifetime, which it's still operating at the moment, kind of knock on wood because it is getting a
Yeah.
little old. Um,
Fingers crossed.
yeah, don't want to jinx anything. But it has spent its entire lifetime in low Earth orbit. So as opposed to Herschel and Planck, which were 1.5 million kilometers away, Hubble is in low Earth orbit around 550 kilometers altitude. Now, the Hubble Space Telescope, over its lifetime, I think it's safe to say the only reason that Hubble is still operating is because it was in low Earth orbit, and NASA for years had the Space Shuttle program that could actually go and send astronauts to service and upkeep the Hubble Space Telescope. It underwent 5 different servicing missions over 1993 to 2009. The first was a really major servicing mission to fix some defects with the primary mirror of the Hubble Space Telescope. Unfortunately, the very first images from Hubble were all super blurry because of this, tiny microscopic little error in the creation of the primary mirror, which just completely messed up all of its imaging and made everything blurry. So the very first Hubble mission was just to essentially just put this corrective optic on the Hubble Space Telescope in order to correct for that little issue with the mirror and allow it to produce these nice, sharp, crisp images. It underwent a few more over the years to do things like replace systems, repair different instruments, replace instruments, and things like that. And then the fifth and final servicing mission was on May 18th, 2009, as part of the Space Shuttle mission STS-125. The STS-125 had basically the primary mission of servicing HST. I believe they also did a couple of other smaller things while they were on this mission, but the primary objective was to refurbish and help the Hubble Space Telescope with a crew of 7 astronauts in total. Now, the crew completed 5 spacewalks over the course of their mission, and just a couple of the highlights of some of the things that they did to HST while they were servicing it is they installed the Wide Field Camera 3, which was a massive upgrade for Hubble. It replaced a previous instrument, the Wide Field and Planetary Camera 2, which, in comparison to the Wide Field Planetary Camera 2, the Wide Field Camera 3, very interesting names for for these instruments, actually expanded the wavelength coverage of Hubble from just the optical to also include some ultraviolet and infrared wavelengths, and also included a larger field of view and a higher resolution compared to the previous instrument. They also installed the Cosmic Origins spectrograph, which replaced a previous instrument that had helped to correct for the issue with Hubble's primary mirror, but wasn't really needed anymore. And in comparison to other instruments that were flying at the time, this spectrograph was 10 to 70 times more sensitive, so really enabled a lot more in science. They also repaired 2 different instruments that had stopped working in 2007 and 2004, and also installed a whole bunch of different backups and space flight systems. So they installed a couple backups to the Science Instrument Command and Data Handling Unit. Sorry about that, which is responsible for basically controlling and coordinating all of the instruments in Hubble and for managing the data on board. So it's a very crucial part of the spacecraft. And they also did things like replace the batteries on Hubble, installed new gyroscopes so it would be able to actually point properly, and also install some protective blankets. So Hubble has not had any visitors or any friends go out to see it since May 18th, 2009 for the final servicing mission. But despite that, it's still operating. The system has had a couple of uh, maybe close calls over the years where things were looking like they were, not so great and a system might be failing, but still even now, many years later, HST is still operating thanks to all of these great servicing missions, in large part the last one as well.
Yeah, yeah, and it's just such an amazing mission. And of course, 35 years. I mean, That's not so long. That's not so old, I might say. But uh, for being up in space, that's a pretty good run.
Oh yeah. Yeah. Especially if we're talking about a lot of these other missions where it's kind of like 4 or 5 year long mission and then there's Hubble sitting here at like 35 years. I don't think James Webb is gonna last 35 years, so Hubble is definitely gonna be a record breaker, even from new
Yeah.
instruments.
Well, and it's as you say, the being close enough to repair was really good for that longevity.
Hmm.
And I don't know, maybe if rocketry advances sufficiently, could refill the coolant for uh, James Webb Space Telescope. But
Yeah.
it would be farther than any human has ever gone before.
It's
So
about
it would be
it's what is it, like 2 or 3 times further away than the moon is from Earth?
yeah, it's quite a bit farther. And so even on missions where astronauts flew around the moon, they didn't get anywhere near the James Webb Space Telescope location.
Hmm.
Um, which is great for being in a dark place away from Earth and the moon. But yes, check the mo scale models of the solar system to get a good idea of how far away it is. It's a long, long ways away, and it would be quite the service mission. It's the sort of thing that um, makes me wish that we had an up and working lunar gateway, because if you did, you would be halfway there, and it would be, if not easy, but easier to get out to things like L2.
Yeah. Yeah, that would be,
Um,
I think we can dream that maybe by the end of the JWST mission there will be capabilities to service it, but I think that might just be a dream.
yes, it is exceedingly unlikely. I
Yeah.
agree. And I would just say that, one of the great things with the Hubble is we did just have the 35th anniversary for Hubble. And I'm sure you saw it, but NASA did issue a Hubble Space Telescope 35th Anniversary Observing Challenge.
Oh.
So if people want, the list of northern and southern hemisphere objects is available all throughout 2025. And NASA has released basically an observing challenge. So any amateur astronomers wishing to undertake the challenge, or professional astronomers, I would just like to point out that the list is available from NASA, and your challenge is for every month for your hemisphere, you try to observe celestial objects that Hubble has seen. And it's selected to be within the reach of even backyard telescopes. So if you've got a sea star or even just a little point and shoot, um, the lists are available. And every month you get a new list for your northern or southern hemisphere. And with the warm weather, this is an ideal backyard star party kind of opportunity. And there's obviously no cost, but if you do the official challenge and you tick it off, I believe you can submit your results back to NASA, and they may or may not have a pin or something that you can get. Yeah, the lists are, I believe it's called the Hubble Night Sky Challenge or the Hubble 35th Anniversary Challenge on science.nasa.gov. So, speaking of the nice weather we're having,
Yeah, I hadn't realized that they were doing that, but that's a really nice idea. Feels like something we could do with the 1 meter, but that's kind of cheating maybe.
that's a
Uh,
little bit cheating. And we'll see how it ranks up on our targets of opportunity.
yeah.
We have already, if you haven't started yet, you've missed a few months of targets this year, but you could always try to sort of catch up next year just to have them all.
Yeah.
And I think it would be an ideal set of targets for something like the 40 centimeter on the Arboretum parking garage, or a well-balanced sea star in a reasonably dark location.
Yeah. 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 But we do have one more this week in history, which I believe is yours.
Yeah, do you want to do the halfway first, or should I go ahead?
Yeah, I could do the halfway first. All right, so you've been listening to York Universe. We're broadcasting live from the Allan I. Carswell Observatory, located in York University in Toronto, Ontario, Canada. Please visit our website, yorku.ca/science/observatory, to join the chat, or if you have any questions or want to see any of our fantastic observatory content. Tonight, you've been listening to myself, Sana Withers, and Dr. Elena Hyde. We've currently been discussing some This Week in Astronomy history, all related to space telescopes. And yes, we've got one more of those before our reminders. So off to you.
Yes, I've picked one more little one, so I'll make this a little bit shorter. Um, Speaking of little space telescopes that could, there's a really interesting one that really didn't get much in the way of press. Going back to 1997, there was something called the low energy gamma ray imager, which had an acronym of LEGRI. And it was launched in the 19th of May, so a few days from now, back in 1997. And of course, we're talking about the wavelengths. This one actually goes the other way. So we were talking about how, of course, infrared goes off towards microwave and then radio, getting longer and longer wavelengths than what human eyeballs can see. But if you go the other way and your light waves get shorter and shorter and shorter wavelengths, what happens is you go from visible to ultraviolet to X-ray, which most of us have heard of X-rays because they help you take pictures of bones, which are about the size of atoms. And you keep going smaller than X-rays, smaller than atoms, to the size of gamma rays. And gamma ray light is around the size of an atomic nucleus. It's incredibly tiny. So this is the other direction, extreme light that we're trying to detect. You absolutely wouldn't be able to see it with your eye. You have lots of nuclei in your body, but other than that, it's very hard to pinpoint something to identify it to. Usually high energy sources. So this little interesting space telescope, LEGRI, was launched by, and I had to check my pronunciation on this, Instituto Nacional de Técnica Aeroespacial, which is um, INTA, INTA, and it's the and in Spanish that translates to the National Institute for Aerospace Technology. So I'm going to call it INTA for the rest of this story because it's a little easier for me. My Spanish is terrible. And INTA, I think, this might be one of only 3 or 4 times they've come up on the show. They've actually done some really cool stuff. Of course, they're located in Spain, apparently near Madrid. And INTA, I just wanted to tell people a little bit about it. It was established back in 1942. It was integrated into the Spanish Ministry of the Air. And of course, one of the things they did was this LEGRI mission. And the LEGRI was put into the payload for the Spanish Minisat platform, which was active from 1997, so when it launched, all the way to 2002. And what they wanted to do was to demonstrate the viability of some of the detectors they had for space astronomy and look at imaging and spectra in this very, very high energy, extremely small wavelength range. And LEGRI was launched successfully, and on a Pegasus XL rocket. And actually, this is another really interesting thing. It was launched on this Pegasus XL rocket. And actually, I said it a little bit wrong way around. The 19th of May was the activation date. So it was actually launched before its activation date. So I have to go back in time because I mixed up my dates a little bit. It was activated on 19th of May, but it was launched in April. And Pegasus XL is a little bit of a fun one because this, again, it's not a rocket that we talk a lot about because it has about sort of percentage of the payload capacity. So it can't carry anywhere near as much up into orbit as, for example, the Ariane or the Ariane 4 that we were talking about before. So the Ariane 4 could carry up to about 4,000 kilograms-ish. But this little, I guess this XL was more of a 400 kilograms. So Legri, a small little mission, demonstrating viability. It was it a very, very interesting test case, I suppose. And the instruments that they were trying to test were all about this really, really high energy process. And so what their detectors are kind of again a little hard to pronounce. It's gosh, cadmium, zinc, tellurium. So they actually call the detector CDZNT. And the crystals were etched into a plane that had, basically a bunch of signal detectors in it, and they could test and see how long they could detect and what kinds of strong gamma ray sources they could find. Look, of course, for things like really interesting high energy signatures like synchrotron radiation from cool sources. And they also actually looked at identifying, finding counterparts in optical frequencies. So looking at gamma ray sources, getting better accuracy on those. And this was big for extragalactic astronomy, especially because you get these really high energy, crazy sources coming out from the far depths of the universe, which I know you know a lot about, Sana. So, so really interesting stuff. And of course, a little mission that definitely could. It was active until 2002, so it did fairly well. And putting it into a highly elliptical geocentric orbit meant that it wasn't super far away, although I doubt that they would have gone up to repair it if it had broken. So a little bit of a shout out to Legri, and of course the INTA from Madrid, Spain.
Yeah, I don't hear as often about like the shorter wavelength observatories. I feel like there's been a whole whack of the optical infrared space missions, but I don't hear as often about things like gamma ray telescopes. I know there's the Chandra X-ray Observatory, which has done tons of cool stuff, but I'm not so sure I can really name many of the shorter wavelength
Well,
observatories.
I think just to have the full pun, this would be truly an observational bias because we're not using him
That's
as
true.
much.
That's true. Yeah.
But I do know that Fermi's probably the most famous, at least, up there in the most famous of gamma ray telescopes. And
Mhm.
um, I'm not sure what its lifetime um, was set to be originally, but I would say Fermi would be the one I would think of as
Yeah.
one of the big ones.
Yeah, now that you mention it, yeah, I definitely remember Fermi. I'm just trying to find its lifetime. But yeah, I
Yeah,
can't.
it was one of those. I think it was supposed to have like a 10-year lifetime or something like that.
Yeah.
But we can, as you go into gamma rays, you're right that the methods for detecting and creating pictures at these extreme high energy wavelengths is very different.
Oh yeah. Yeah. It's definitely much easier to create like pretty pictures with optical telescopes, which might also be why I can't necessarily name some of the longer wavelength ones, but I know there's been
Yeah.
a few sort of, you take a Hubble Space Telescope image and add data from Chandra on top of it, and it looks so cool. You can really see the different kinds of, X-ray or gamma ray radiation that's around an object. It looks so cool when you add those in.
Oh yeah, and I know that X-ray I know a little bit about because I actually got to work on the Rosita spacecraft, and that's X-ray. And the interesting thing about it is with X-ray and gamma ray as well, you can actually use silicon detectors, but they're built very differently. And in a lot of cases, it really is like single photon counting. So
Hmm.
you're actually able to just be like one one photon. Two photons. So it's a very different astronomy experience, shall we
Yeah.
say.
Yeah. But lots of so I think we've covered pretty much the full electromagnetic spectrum in the this week in
Yeah,
history.
we went from
Um,
radio to gamma rays. If anyone else wants to go into gravity waves, we'll do a different episode. But we should probably do some reminders.
Yes. Okay, so I've got the first reminder, which is our Wednesday tour this week. We're running a tour at the observatory in person from 8:30 p.m. to 10:30 p.m. this Wednesday. I think that's the 14th. The tours are free as usual for the Wednesday night tours. And if you would like to stop by, please just get tickets in advance. They are free, but we do need to sort of know how many people are coming when, because there is somewhat limited space up in the observatory. So if you'd wanted to come see the 1 meter and 60 centimeter telescopes, please just visit our website, and there are will be links to the Zephy page for the tickets. And then you have two reminders as well, I think.
Yes, extra reminders for the Allan Carswell Observatory. Very exciting times are afoot. We have a lot going on this summer. Actually forgot to put in that we're going to be taking part in Doors Open Toronto on May 24th. And right after that, our first astronomer in residence is actually going up to Killarney Park on May 26th. So the new astronomer in residence blog will be active, all happening this month. And even before that, by the end of this week on Friday, our open air Astro Fair tickets are going on sale. And that's going to be on the same website that you've been getting all over the intro and outro and everywhere else. So we're actually selling tickets. So this is our only event of the year that's not free. Um, so please actually buy a ticket if you want to go. But the open air Astro Fair will be at York University on the first clear day from June 24th through July 4th. And whichever of those days is first clear, that's when we're going to be having a absolutely massive open air fair with a planetarium and stations, and it should be really, really fun, and all the proceeds go to support the observatory. So if you want to get your tickets early to make sure you get the slot you want, just check the website on Friday and it will be up and available to buy.
Yeah, that's I'm looking forward to Open Air Astro Fair. It's going to be fun.
Yes, it's going to be very, very chaotic, but really, really fun because we do have, I think, counting the James Webb Space Telescope booth,
Mm.
of 10 different areas of
Oh, wow.
astronomy and activities.
Yeah, so lots of things to do.
Yes, exactly. And once you have your ticket, it covers all the activities. So you can come and get experience everything. Obviously, if you want to buy posters or something, that's a little extra, but all the experiences and the science and the observing and the planetarium are all covered, and all the free activities are covered. We're going to have make your own foldable sundials and astronomically accurate fortune tellers. So it should be a really good time.
Yep. Yeah. All right. So that's it. I don't have any more reminders. Are you good as well?
Oh yeah, I'm good. So let's do some
Okay.
news.
Yeah.
And we're talking of space telescopes. Wow.
Two more news items, both related to space telescopes. So first up, we've got JWST observing aurora on Jupiter. So there's been a couple of observations out of JWST having to do with Jupiter. It looks really cool, a little bit wacky almost in the infrared. But one of the really cool things that you can do in the infrared with about Jupiter is observe the massive and really, really bright and powerful aurora that are on the poles of Jupiter. Now, these observations in particular were taken on December 25th, 2023. And just a couple of days ago, actually, I think this morning, there was a really cool video of the aurora on the North Pole of Jupiter from these December 25th, 2023 observations. So it's a really awesome video. I definitely recommend looking it up. It looks really wacky to see, something as massive as Jupiter having these crazy aurora that are varying so quickly. Um, but just taking a bit of a step back, The aurora on Jupiter are formed in a pretty similar way to any sort of aurora or northern lights that you would observe here on the Earth, which is just that charged particles from our sun in the form of solar wind are sort of, being flung outward towards Jupiter. Jupiter has this very powerful magnetic field that sort of funnels all of these charged particles towards its the poles on Jupiter, and then that these charged particles can start to interact with some of the gases in Jupiter's atmosphere, which then start to get very bright and emit these beautiful aurora. So very similar to what happens here on the Earth, where the Earth's magnetic field will funnel those charged particles towards the poles and generate the aurora. But on top of that, one of the key differences between the aurora on Jupiter and the aurora on Earth is not only are the aurora on Jupiter much, much more powerful and much brighter than what you see on the Earth, but they also can sometimes be formed because one of Jupiter's moons, Io, has active volcanoes which can eject charged particles into space, which then go on to cause the aurora on Jupiter. So this is a little bit wild that there is a moon that is ejecting charged particles that can actually form aurora. I think that this is really, really cool. But that's the way that aurora on Jupiter are caused. Now, like I mentioned, they have been observed several times before, but what's come specifically out of these observations is something that's a little bit unexpected. So, this is unexpected in two different ways. First of all, the aurora seem to be much more dynamic and change a lot faster than expected. The astronomers who were responsible for getting these observations kind of thought that they would see some sort of variation over the course of around 15 to 30 minutes, but instead they were seeing much shorter period changes, even some changes happening over the course of just seconds. So one of them actually described it as the aurora looked like they were fizzing and popping on Jupiter, which is just not something that anybody had expected to see. On top of that, JWST also paired up with the Hubble Space Telescope to observe the aurora on Jupiter to see if they could understand what was causing the aurora just by observing it in a different wavelength of light. So in particular, with the Hubble Space Telescope, they were observing the ultraviolet component of the aurora. But to their great surprise, they didn't actually see much in the Hubble Space Telescope data, which is very unexpected. And what this implies is a very specific set of conditions where Jupiter's atmosphere is basically just getting bombarded with lower energy particles instead of higher energy particles. So these lower energy particles are becoming very bright in the infrared and producing these super bright infrared aurora, but they just are not energetic enough to produce ultraviolet aurora that would be observed by Hubble. So it's a bit of a weird sort of set of circumstances where not only are the aurora just, varying, or they're a lot more active, I guess, and they're varying a lot faster than people would have expected, but they're also a bit of a unique set of physical conditions to actually cause this. So it's currently still a bit of a mystery as to exactly how the very bright infrared but very, very faint ultraviolet aurora are actually being formed and exactly what's going on there. And it's going to require a little bit of follow-up observations, possibly to learn more about the magnetosphere on Jupiter, which is just its massive magnetic field, and how that influences the different types of charged particles that go on to form these aurora. So this is a very interesting set of observations out of the James Webb Space Telescope and the Hubble Space Telescope. And definitely look up that video. I believe it was posted on the NASA JWST Instagram page, which is I think where I saw it earlier today. But it's a really, really cool video.
Yeah, and they do have it on the website as well. It's absolutely worth catching, and it really does. It reminds me of that I don't know if they still have them, but the old-fashioned candy pop rocks. It's, and it was just like, sort of this dynamic. I don't know. I wouldn't use the word fizzy because it's obviously in space, but dynamic, almost fizzy type of looking reaction. Very, very interesting stuff. And of course comes with beautiful visuals.
Oh yeah. Yeah, it's a really interesting thing to see. And also, interesting to think about that this is all in the infrared, right? We couldn't actually
Yeah.
see any of these with our eyes. So that in itself, they are slightly different than the kind of aurora that we, typically observe, and we can just see ourselves on the Earth. So you need to look in infrared wavelengths to see these kinds. So really interesting.
Yeah, and especially, for those people who are really motivated thinking about space settlements and habitability, the high radiation belts that this helps set up around Jupiter would
Mhm.
definitely affect any possible Europa surface settlements, for example. Obviously, Io surface settlements would be more affected, but they would also have like a lava problem. So.
Hmm. Yeah, I don't know if you find that as kind of weird or shocking as I do, but it's very, very interesting that one of Jupiter's moons is causing aurora.
Yeah, well,
I,
it totally makes sense because it's spewing out all that volcanic material into where the magnetic field of Jupiter can pick it up and accelerate it and do interesting things with it.
mhm.
But yeah, this kind of icy outer solar system reactions that you get when you have lots of gravitational heating and interesting dynamics. I agree, it's really fun.
Yeah, yeah.
Speaking of fun,
Yes.
I I have one more fun thing to say, and of course we're always running out of time on this show, but I couldn't leave without telling everyone about the Transiting Exoplanet Survey satellite newest discovery because they have now just published a new set of exoplanets in the ever hunting, sort of ever evolving hunt for alien worlds out beyond our own solar system. There were two intriguing exoplanets that have terrible names. Orbiting a relatively nearby 220 light years away, so pretty far away, relatively nearby sun-like star that's only 220 light years away. But both of the exoplanets are seem to be quite Earth-like, and the star is quite Sun-like. So the two planets are HD 35843 and TOI 4189. So terrible names. And the NASA's Transiting Exoplanet Survey Satellite, or TESS, has been really racking up the exoplanet detections. It's been a real game changer in exoplanet science. It has right now 7,600 candidates that it's trying to confirm to see if they are really planets or just noisy signals. Um, so the two new planets that they have found are a few times more massive than our own Earth, orbiting a star that's not too different from our star, which of course is immediately you're like, oh, could it be something that is, in a habitable zone? So that's one of the things they're trying to figure out. The star isn't exactly an exact analog to our own. It's a metal poor star, so it has less metals in it, so the planets then might be less metal rich. And they actually were able to measure its radius fairly precisely. It's about zero point 0.9, so almost the same size as our star, a little bit less mass, but very, very comparable. And they confirmed that there were real planetary detections by following them up with ground-based telescopes, which I like because, of course, we have a ground-based telescope that can do follow-up. And the confirmed exoplanet is about 2.5 times larger than our own Earth, but that's not, it's no Jupiter, right? So it's just a bit larger than Earth. Um, and it seems to be a bit more dense as well. And then the other planet, which was non-transiting, so this was a harder detection, I imagine. This one has 5.84 Earth masses, which is an interesting, almost sub-Neptune type of size. They think that it might be close enough to the star to be kind of maybe a water world, which would be cool. Obviously, we can't see it. It's far too far away for any kind of direct imaging. but it's a really, really interesting system with a really, really interesting spectroscopic signature because they actually had some spectroscopic metrics, and they are hoping, and this is a tie-in back to you, Sana, they're hoping to get follow-up atmospheric characterization with James Webb Space Telescope because, of course, telescopes are awesome and space telescopes are really, really awesome. And telescopes do make the best spaceships. So there.
Well, I think that is the perfect way to end off tonight's show. Really, really cool. Exoplanets are awesome. Uh,
Yes.
so, but that brings us to pretty much 10 o'clock. So everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Dr. Elena Hyde and myself, Senna Withers. You can always connect with us on Instagram with the handle at YorkU Observatory and on Facebook at Allan I. Carswell OBS. You can also check out our website for show notes, content, updates, and contact information at yorku.ca/science/observatory. Thanks for tuning into York Universe, clear skies, and have a good night.
Clear skies, everyone.